Okay, let's get started. So how do we do on this? Which of the following are quantities? Okay, so I'll tell you that two of those are quantities. Did you pick two? If you picked one or more than two, you made an error somewhere. There's two quantities here. What about meters? Is meters a quantity? No, meters is a unit of measure, right? Meters. Okay. What about race car? Object. It's an object. What about width? Okay. It's not well defined, but it is a quantity, right? It's a measurable attribute of an object. Width. That's right. What about 500? No. So that, before you came into the class, you might have said that's a quantity, right? That's not the way we're defining quantities. When we say quantity, we don't mean just a numerical value. We mean a measurable attribute of an object, something descriptive about an object that we can measure. What about 17.6 seconds? No. Okay. That's a measurement. That's a measurement. That's not a quantity. What about acceleration? Yes. Yeah, we can measure that. What about the 18,000 fans? This is essentially saying the fans. The fans. Are the fans a quantity? No, so how can we change that to make that a quantity? How can we restate that so it would be a quantity? Yes, sir, in the back. The number of fans. The number of fans now is a quantity. But the 18,000 here is just a description about the object. That's not a quantity. So those two are quantities. Remember that a quantity is a measurable attribute of an object. And this is what the course is about. The course is about quantities, the whole course. Okay, but we want to make sure they're well defined. So width, where it is a quantity, it wouldn't be descriptive enough, right? Descriptive enough. So here's a better description. Width of the race car over its front axle. Right? No question what we're talking about now. Acceleration. Acceleration of the race car during the last lap. These are better. These are well defined now. Well defined. Okay, let's talk about the syllabus, and then we'll put you back to work. I'm not going to read through this whole thing. I'm going to touch on the most important parts. So I just updated that last night with the right room number. We will be here all semester. This is permanent change. Okay. My office hours, Monday, Tuesdays, and Wednesdays, 2:45 to 4:15. Okay. Also by appointment. Okay. So if you need to see me more urgently or that times don't work for you, then by appointment. We should all have this workbook by now, and you're going to bring it to every class and every recitation. Okay, so we might not use it every single class, but we will be using it, so just bring it every time. Pathways workbook. So you will need a graphing calculator, so a TI 83, 84 is probably what most of you have, and that's good. There are calculator workshops. If you want to attend, here are the times and dates. So that this is more for basic understanding. Like if you've used it for a whole math class, you probably won't get much out of it. But if it's the first time with a graphing calculator, this will be really helpful for how it graphs and different features that it has. So make note of those, the calculator workshops. Okay, so with the workbook, so Blackboard we've already found. That's where our home base for the course. Rational Reasoning website, that's associated with the workbook. And there's an actual kind of text, an online text that goes along with that. So if you want, it has some videos and some animations that go along with that. So, and I may be possibly signing things from the text. So you need to get a login that you get by your code that you found in the workbook, so that you have an account with them. And so just stay tuned. I'll put that in Blackboard in the assignment area. I'll tell you, I want you to read these pages, okay? So be ready for that. Web work we've already found. And there was lots of success on the web work. I think 20 to 25% of you got 100% credit, okay? So I think we're off and rolling on that. Attendance is going to be crucial. Even though I am videoing the classes, you have to come, and I will take attendance. And just be ready to be engaged in class. This isn't going to be a class where you can just sit back and copy what's on the screen. So I'm going to ask questions of you. I'm going to put you to work in class. So just be ready to learn. So we're going to make class is going to be something much more valuable than just a set of notes that you walk out of here with. Okay? So be ready to get involved in class. Homework, written, and web work. Just get used to web work being due every class period, 8:45 a.m. And then we're going to do written homework once a week. I think we'll make it due on Fridays. Okay, so written work will also be due on Fridays. And I will try to post that early in the week so you can get started on it. So I won't post it, Wednesday night or something like that. I'll try to post it earlier. And you'll have written homework, and you'll turn that in lecture at the beginning of lecture. Okay? There is a tutoring center for this course. So as you're quickly discovering, this is maybe different than math classes you've had in the past. We're framing everything in the real world. That's where we're starting. And we're just trying to make it really relevant and not just learning a bunch of procedures. Okay, so be ready. There's going to be a different class. And because of that, we offer a special pre-calc help room. And the tutors there are trained as best we can. We have the best people that we can to trained up for this curriculum. Okay, so that's in PSA 21, and that's in the basement of PSA, which is on the Palm Walk. Let's see, so it's on the Palm Walk, kind of close to the walking bridge and University, a little bit south of there. That has not opened yet. I think that opens maybe this Thursday. So it's not open yet, but it's got great hours, like 9 to 6 almost every day, and then 9 to 1:30 Friday. So you want to take advantage of this. There may be other resources you can get for help, but chances are that the tutors that you get help from outside of here won't be familiar with this curriculum, and so that may cause difficulty. So take advantage of this, and then Jerome will hold his office hours here. Do you have them yet?
I don't have
Okay,
them.
so as soon as Jerome gets his hours, he's going to hold hours here. As soon as he gets his hours, I'll let you know about that. So besides, your best chances for help are this pre-calc help room, Jerome, and myself, my office hours, okay? So take advantage of that. You can just go and just do your homework there. You don't have to have questions, and then as you have questions, you can call a tutor over to help you. So if you just want to go there and just do your homework, that's great. You can do that. Okay, our exams, we're going to take our exams in recitation. Okay, in recitation. But here's the deal with that. So that you have enough time, on those exam days, you got to go to recitation early so that you have enough time. So you're going to go 15 minutes early on these dates, September 19th and 22nd, 24th and 27th of October, November 21 and 24. So I will remind you in lecture about that, but just keep that in mind that because we got the long passing periods before and after, we can take advantage of that. You get more time on the exam, okay? So go, so what do we normally go at 10:30, is that right? 10:30 is when recitation starts. So plan to start your exams on these days at 10:15, and then you can have till like 11:45. That should give you enough time to get to a noon class if you have a noon class, okay? So, and then we'll take a post-test. We got lots of time. It's at the end of the semester. I'll tell you about that. But just note these dates, and we'll do exams and recitation. Okay, so the exams are going to be worth 40%. The final's worth 20%. Your homework, which is all the written and web work, 25%, and then quizzes and attendance, 15%. So everything's got a lot of value, okay? Here's some important dates and important stuff that you're responsible for: academic integrity, when you can drop, incomplete, all that stuff. You're responsible for it, but I won't read through it. Any questions on the syllabus? Okay. So get out of here. Okay, so let's keep practicing this stuff about quantities. So people who succeed in this course are people who can attend to changing quantities and define changing quantities with variables effectively, and then keep their attention on that, your focus on that as you're solving the problem. If you have a procedural mindset about solving problems, first you do this, we got to break that as soon as we can. And instead, we look at a situation and we determine what are the quantities that are important. We want to define variables well, okay? And then as we solve the problem, we're staying focused on the quantities and how they're changing. Okay, so this will do all semester. So let's practice more of this. I've got a video here. Let me start it over so you can see it from the beginning, but we'll watch it a few times. Maybe. Okay, so we got a couple runners here. And they're running through a tunnel.
Left.
And then she gets lost. She finds her way. So these ultra marathoners, they run like hundreds of miles at a time, right? They just keep running and running and running, like Forrest Gump. Okay, so this is one of these races. That's one more time. So I'll play it as I put you to work. But what you're going to do is you're going to define 6 distance quantities and 6 time quantities. 3 of your distance quantities will be constant distance quantities, and 3 of your distance quantities will be changing distance. And we'll define variables for those changes. And then 3 of your time quantities will be constant, and 3 of the time quantities will be changing. So I'll write them down.
Left.
Okay, so I'll play this so you get we can. So 3 constant distance quantities, 3 changing distance quantities, and define variables for those. Okay.
Left.
Next to you, compare work together. A couple minutes to do this.
Left. Left.
Okay, now I'm commanding you to meet someone next to you and share what you did. Everyone
Left.
say one thing about these. I'll let you go again, but one thing that's really important about especially distance and time quantities is that part of you're defining it, you have a reference point, a starting point. Distance from where? Time starting when? Okay, so that's in terms of being specific enough. We talked about one of the criteria for defining a good variable is being specific. When it comes to distance and time, this reference point is always needed. Where does the distance, where are you measuring distance from? Where are you starting measuring time from? Okay, that's whether it's constant or changing. Okay, go.
Here. Left, left. Here. Left, left.
Okay, where's Arturo? Where's Arturo? Tell me one of your constant distance quantities. So what'd you come up for a constant distance quantity, Arturo? So what? So you be more specific. Start of what to finish of what? Still not sure where you're thinking about starting and finishing. Okay, so the distance ran from when video started to when video ended. What do we think? Is this good? Okay, well, we're not defining a variable. So remember, if you're just talking about a quantity, you don't need units. It's the units we need when we got a variable, because a variable is going to take on values. So what we really want for sure here is not necessarily units, but it's got to be specific enough. Is it specific enough? Right. So there was a man and there was a woman. Did they run the same distance? No. Okay. So she said the man ran further. Okay. So distance ran by. We got to specify. So Arturo, you want the man or the woman? All right. Okay. What about now? We like it? I think this is fair. There's no question what we're talking about. How far do the women run starting at the beginning of the video to the end of the video? Where's Hamid? Hamid Q. Tell me another constant distance quantity that you said, something different than this.
The distance run by the man from when he entered the tunnel.
Okay, so the distance that he ran from the start of the tunnel to the end of the tunnel. Okay, so maybe that's just the distance from the beginning to the end of the tunnel. From start of tunnel to the end. Is it constant? Is it specific? Do we know exactly what we're talking about here? Sure. It's Good one. Okay, so let's do some, is there another constant distance quantity that someone's dying to tell me? What's that? He wants the width of the tunnel. Constant? Specific enough? Width of the tunnel. These are all constant distance quantities in this situation. Okay, changing. Let's go with, where's Bradley West? So changing, we're going to do a variable. So let's actually define a variable here. So what do you think a changing distance quantity in the situation is? We want distance. So not time. Time's coming later. We want distance. A changing distance quantity in this situation. What's your name right next to him? Yeah. Was it? TJ. What do you think? Distance between the runners. All right, so what do you want to call that? What variable? X. X equals distance between the runners. Is it changing?
Yeah.
How do we do on defining the variable?
You need units.
Need units. So what? Inches. Sure. Distance between the runners in inches. Is it a quantity? It's changing distance quantity. Is it specific enough? And does it have units? We're good. Okay. Let's do something else. So distance between the runner in inches. That's good. Where is Daniel? R. You got another changing distance quantity in the situation.
That's the distance from the starting point of the bridge for the woman.
Okay.
Meters.
Okay. So what variable do you want to call that?
Z.
Z equals the distance of the woman in meters from start of the bridge. Is that what I heard you say? Okay. Is it a changing distance quantity, first of all? Is it specific enough? Is there any question about what distance we're talking about here? And does he have units on it? Yeah. I'll write it out. Yeah, this is a good changing quantity. The distance that the woman is in meters from the start of the bridge. We'll say that's the variable z. And so then z takes on, maybe that's, we can assign positive and negative to that. So when she starts the video, maybe it's, like -5 meters, right? And then when she crosses the start of the bridge, z equals what? When she's at the start of the bridge, z equals 0. And then she's going to run 1 meter past the start, and then 1.5 meters, and at one point she's going to be 8 meters, right? So z is taking on all these different values of her distance from the start of the bridge. -2, -1.5, -0.1, 0, 2, 5, 6. As she runs, z is changing. Z is taking on all those different values. That's the way we want to think of a variable. Not so much, and so it is valid to say that a variable stands for the value that solves an equation. So that is a value. But really, we want to think of it as it takes on many values, and only one of those values solves the equation. So then that definition is then coherent with this, that z is taking on many values. Okay? Let's do one more changing. Where's Natalie? Natalie Fain. Yeah.
I said the distance of the woman from the exit of the tunnel.
Okay, and what do you want to call that? M. And so I think the guy's feeling a little lonely here, so can we change it to be the man?
Yeah.
All right, so the distance of the man in meters from end of the tunnel. Good, well-defined variable. Got our units, it's well-defined. And so notice, again, on these distance quantities, you always have that reference point. So distance between the runners, distance from the start of the bridge, distance from the end of the bridge. Okay, let's do time quantities. Constant time quantities in this situation. Where's Tyler G? Tell me.
Time in seconds, the man spent in the tunnel.
Time in seconds, man spent in the tunnel. How do you do? Good? That's good. That is a certain amount of time. It's not changing, and it's specific. We know exactly what we're talking about. Somebody else. Margarita.
The time from the start of the video.
Okay, so the length of the video. That length of the video is a certain amount of time, whatever it is, 52 seconds or whatever it was. Okay? Changing, let's define some variables here. Devin C. Where's Devin? All right, you got a changing time quantity. So a variable that we're going to say it could take on 0 seconds, then 1 second, then 4 seconds, then etc.
The total amount of time the woman runs after leaving.
Okay, so what do you want to call that? What?
Alpha.
Okay, so how about an English letter?
T.
What?
T.
C?
I said T.
Oh, you said T, sorry. So T equals, and you're saying the time in hours since what?
That she spends running after she leaves the tunnel.
Okay, that the woman runs after leaving the tunnel. Let's make sure, is this changing or constant? The time in hours that she runs after leaving the tunnel. Changing or constant? Changing. It's so a couple seconds after, that's some fraction of an hour that she's run, and then a minute later, it's 1/60th of an hour, and then an hour later, it's 1 hour, right? So this is, and we've got our reference point, right? Since she leaves the tunnel, that's when time starts. That's what we need on time quantities and distance quantities. Starting point. Okay, another changing time quantity. How about Walter?
B equals time it took Mel Runner to reach the tunnel. Time in seconds.
Time in seconds. Okay, how do you do? They're saying it's constant. Is that constant or changing, Walter?
It's constant.
It's constant. So how can we change that to make it a variable that takes on many times? So time in seconds. How about since the man did something? So Walter, since the man
Reached the beginning of the tunnel.
entered. Okay, so we say entered the tunnel. Yeah, I mean, yeah. Since, yeah. Now that's changing, right? Because now he's in the tunnel, and that as time goes by, that B is taking on all those times since he entered the tunnel. So this is defining variables all semester long. All semester long, we're defining variables as changing quantities, and we want to be this specific and practice this. And then this is our focus as we're solving the problem. Okay, what exactly do those variables mean? They take on all these different values as the situation unfolds. Okay? Any questions on this? Defining variables for changing quantities. Okay, so let's take this a step further here. It's in the wrong spot. Can you read that? Is that big enough to read? Barely. Okay. So we're going to let... blank page. I've defined a variable here. Z is the amount of rainfall in Tempe since August 1st in centimeters. How did I do defining my variable? So what were the three criteria? The first criteria is it a quantity itself, or is it an object? So I'm saying the amount of rainfall. Is that a quantity? Yes, okay. And in Tempe, since August 1st in centimeters. Is it, so second criteria for defining variable? Specific, yeah. A reference point, specific. Is it clear what I'm talking about? Yep. Do I have my units? Got a good variable here. So this down here, I've got this this like number line, and I can change where that red bar stops. So what might I be representing right now by that red bar? What do you suppose I'm representing relative to this situation? Right, 9 centimeters. So at some point after August 1st, the amount of rain in Tempe had hit 9 centimeters, and that's what I'm showing right here. Okay, so follow-up question. Now I got a blue bar. We're talking about the variable z. I'm not talking about any other quantity, but the one that's represented by variable z. What might that blue bar represent? Okay, so one person. What could the blue? Yes.
Different date after August 1st.
Okay, we're not talking. It's just about rainfall. Okay, so a different date. What do you? So this is just about the rainfall. Yes, sir.
It doesn't rain.
It doesn't rain. But this scale is for amount of rainfall. Amount of rainfall, and so now I'm highlighting a section of that scale over here on the side. Average amount of rainfall. Other idea.
Amount of rainfall on August 1st.
Amount of rainfall on August 1st. Let's look at the start of that bar. The start of that bar, what does it represent? So right there, the start of the bar, according to this scale, what does it mean? Yeah. It means 2.5 centimeters, the moment when 2.5 centimeters had fallen in Tempe. That's what the start of that bar means. That might have been on August 10th. That might have been on October 1st. We don't know when. So that we don't have any associated with time here. It's just the start of that bar on that scale means that z equals 2.5, right? What about the end of the bar? 5.5. Z, so this is z equals 2.5, and this is z equals 5.5. So let's try again. Anyone have a new idea? No one's really gotten it yet. Yeah.
Could it be like one day of rainfall, like one specific day?
One specific day of rainfall. Maybe so you're saying maybe this was one particular storm.
Yeah.
Okay, now we're getting closer. Another idea.
Specific date range?
It's nothing to do with dates. This is about amount of rainfall. It started at 2.5. So we're highlighting when there was 2.5, starting when there's 2.5 until there was 5.5. Yeah.
The amount of rain before that.
The amount of rain before that. Yes, sir.
The amount of rain that came down from a specific storm.
Okay, yeah. So someone that said that, yeah, that could be. But so in general, this is really highlighting, the blue bar is highlighting the change in amount of rainfall. So we have the quantity itself. Right now, what quantity are we talking about? What's the value of z right now? What's the value of z right now? 9 centimeters. What the blue bar is highlighting is some point before that, there was 2.5, and then there was a certain amount of rain up till there was 5.5. And so that's a change in the amount of rainfall. A change in the amount of rainfall. How much was the change? 3 centimeters. Okay, and so our notation for a change in a variable or a change in a quantity, we use Greek delta. So the blue bar is a new quantity, which we call delta z. Delta z. And so delta z is the change in the amount of rainfall. In this case, I'm highlighting the change from starting when z was 2.5 to when z was 5.5. Does it make sense? Okay. All right, so now I'm going to say, all right, how much rainfall have we had now? 6. Okay. What does the blue bar represent now? Okay, it's still a change. It's a change in the amount of rainfall. Specifically,
Change since 0.
so what's that?
Change since 0.
Change since 0.
Since August 1st.
Okay. And how much of a change was it? Oh, so it's the same value as before. So here, delta z is still 3, but it's a different 3. Which 3 is it? The first 3 inches. Now I'm showing the first 3 inches of rain that fell, but the total amount that's fallen so far is 6.5. But I'm showing the first 3 centimeters that fell. Okay, so this idea of formalizing the change in a quantity is really important in calculus. I mean, this is the crucial building block of calculus. That we have these quantities represented by variables, but then we look at we highlight a change starting at one value of the variable or the quantity to a final value of the quantity. Okay, so another situation here. That, and then we'll this. Good, and then do this. Darn it. Sorry, it's touchy. There we go. Okay, so this, let's say that this is 1 point, z equals 1.87. And then this is z equals 6.23 centimeters. Okay, find the change in rainfall amount that I'm representing here. Find the change in amount of rainfall. Go, everyone do it. What does delta z equal? Someone had it up here. Eric said 4.36. Did you get that too? And so you didn't have, most of you didn't have to think, it just naturally you knew how to find the change. And so let's kind of define that. So Eric, what did you do to find that change in rainfall?
Subtracted 1.87 from 6.23.
He said he subtracted 1.87 from 6.23. Right, so to get this span of the quantity, and what does the 6.23 represent here? How could we kind of formalize what that thing is? What is 6.23? Yeah.
Z final.
Yeah, it's the final value of z in this change, right? So we mark that with a z. We could say a little final there. Z final. And 1.87? Z starting, Z initial, something like that. It's the starting value. So this is how we calculate a change in a quantity. We sometimes, okay, sometimes. So we take the final value of the quantity, subtract the initial value of the quantity, and that gives us the change in the quantity. Trying to find somewhere that. I guess that's not going to happen. Okay, so say this is 3.2. Okay, and this is 7.2. So this is a little bit different. So talk to the person next to you. What might I be representing here? So what might this whole thing represent? Go talk to the person next to you. What's happening here? This is a little different. Okay, what did you come? Somebody new. What did you come up with? Yes, sir.
Estimated change in rainfall.
Estimated change in rainfall. Can you say more? So give me a whole. Just give me the whole picture. Like use the values.
4 centimeters would be the estimated change in rainfall.
Okay, so he's like the future kind of.
Yes.
All right. Any other ideas? Yeah.
The difference between two beings in a one-dimensional world.
Okay, that was kind of funny. What else? What else?
The average amount of rain and change in the average.
There's no averages here. So what does the red bar represent again? How much rainfall we've had since August 1st. So we've had 3.2 centimeters. Okay, we've had 3.2 centimeters. And what is the blue bar saying? A change, right? So in this case, it's kind of like an additional amount. Like we've got so much, and like you said, we're like predicting like maybe the next storm, or this is the next storm maybe, 4 centimeters additionally. Okay, so this is z equals 3.2, and then we get an additional amount of how much? 4. And so then we could say, okay, so now what's the new value of z? 7.2, right? Okay, any questions on this? So just this, it may seem like a simple idea, but it's a really important idea. Yes, sir?
So it's basically not really predicting the future, but it's saying that it's either happening now or it can't happen. It's changing 4 centimeters.
Yeah, so what we're saying is the current amount of rainfall in Tempe is 3.2. And then whether it's a prediction or whether it's the next storm, it could be either of those. It could be like a prediction, or it could be the next storm or something like that. But it's an additional amount of rain that comes along. So now the new value of z would be 7.2 after that happens. Okay, so some of you have recitation today. You're going to recitation. And then there's web work for Wednesday.